Before we actually configure the fuel table, you need to decide what parameter you'll use as the load axis on the table. If you change this later on, it will affect your entire tune, so you want to get this right first. The correct option is going to depend on your engine configuration, but 90% of engines are going to use manifold pressure as the load axis. Manifold pressure is an essential element of the speed density principle, so it makes sense that the ECU wants to see this value to calculate airflow through the engine. While it isn't a popular choice for an aftermarket standalone ECU, it is possible with some ECUs to use a mass airflow meter. There are very few instances where you would want to do this unless the rules for a particular class dictate that removing the MAF and adding a MAP sensor are not legal. The other option that is occasionally used for the engine load is throttle position. This is also known as alpha N. You would only consider using throttle position in an engine that runs multi-throttle bodies, where the engine vacuum is no longer a good reference for engine load. It can also be useful in heavily cammed engines which produce very little vacuum at idle. If you're running an engine that uses both multi-throttle bodies and forced induction, you will need to use a more complicated model for fuel that incorporates both throttle position and manifold pressure. This is an advanced topic that is beyond the scope of this course though, and is only something that should be attempted by experienced tuners. In our example, we're going to be using manifold pressure for the load axis, but we also need to choose an appropriate range for both the load and RPM. Your ECU will have a menu that allows the axis of the tables to be changed, and we just need to go to this to start with. If I'm not familiar with an engine, I will start by adding RPM zones every 500 RPM from 0 through to 500 RPM beyond the expected rev limit. It can also be useful to add an extra zone in around your desired idle speed to improve accuracy of tuning at this point. If we are using manifold pressure for the load axis, I will start with load points every 20 kPa and then add another couple of load points around the idle and cruise areas of the map. The actual manifold pressure the engine will use for idle and cruise will depend on the engine and the cam overlap, so you will need to test and adjust this. I would start by adding zones at 30 and 50 kPa. If you're using throttle position for the load axis, the load points are a little different. The airflow through a throttle body is very non-linear. This means that you get a large increase in airflow over the first 50% of throttle travel and much less of an increase over the remainder. To be able to get really good fuel control and smooth drivability just off idle, I will use load zones of 0, 2.5, 5%, 10%, 15 and 20. This gives very fine resolution down near closed throttle where we need it. Above 20%, you can then add zones every 10% to give 30, 40, 50 and 60%. Above this, we can expand the resolution and add zones at 80 and 100%. You'll most likely find when it comes time to tune that the fuel numbers don't actually change between the 80 and 100%. They're basically almost identical. Now that we have our axis set up, the next job is to enter some numbers into the map that will get the engine running. This is the part that novice tuners get worried about, assuming that they need the perfect number in the map to get the engine running without the risk of damage. As you'll see in the initial startup module, this really isn't overly critical, and we're going to see what to do to get these base numbers dialed in really quickly after startup. For a VE-based fuel map like we have here, you can expect most engines to idle with a VE of around 40 to 60%. We also know that around peak torque we can expect to see VE hit somewhere around 90 to 100% depending on the engine design, but without getting too fussy, we can simply enter a VE of 50% across the entire map for now. For a millisecond-based fuel map, choosing numbers for the fuel map is a little more involved, since the numbers in the main fuel map are going to depend on the size of the fuel injector, the base injector pulse width, and the VE of the engine. It might sound like a lot to take in, but we aren't going to get too tied up on this. We'll be able to sort out the specific tuning once we have the engine running, so for now we just need some numbers that will get us going. Usually we'll find that the idle area of the map will have numbers in the range of 20 to 40%, so we can start by getting the entire map set to 30% for now. While we are going to need to revisit the fuel map in more detail once we actually start tuning, this is all we should need to get our engine started and running.